And
Okay.
we are recording.
All right, great. Hi, everybody. My name is Renee, and I'm a program specialist at Girl Scout Spirit of Nebraska. And this program today is going to be all about the sun. Krista is a Girl Scout mom, and she is one of the leaders of our astronomy clubs, the leader of our astronomy club here in Spirit of Nebraska called Beyond Our World Astronomy Clubs. So we hope you are staying healthy and safe and active, and we're glad that you're watching today. And Krista is gonna take it from here. She's got a lot of really amazing information for you, and I think I saw a big poofy sun ball or something like that. Yeah.
Yeah, this right here is my my cool green screen is kind of making it all weird. But this is my celestial buddy. There's his face. I've got a
I love it.
collection of them, so we'll do themed celestial buddies. You can sit here.
Okay.
And oh yeah, he's sitting here with my daughter. Did her flat Juliet, so she's joining us too today. So we'll have them joining off to the side. So
Good.
welcome.
Take it away.
Okay. Welcome. As Renee said, my name is Krista Teston, and not only am I a Girl Scout mom, I run the UNO Mallory Kuntz Planetarium here in Omaha. And of course, we're shut down just like everybody else that's doing public educational activities. But I'm also representing Solar System Ambassadors. NASA Solar System Ambassadors is a volunteer program. So we're volunteers from around the US. I think there's even some outside of the US that represent NASA as an educational outlet for resources and information. We give presentations as they come up. So I just received my ambassador program. So I got a cool badge and a patch, and I'm ready to start teaching and educating just like I do for my regular job. Today, we're going to use my hat as a Beyond Our World Astronomy Club leader and my solar system ambassadorship now to present stuff about the sun. And I've got a PowerPoint here that I'm gonna share out if I remember to share it. You know what? Give me just a second here. Nope. I've got this. Finally, it took me 3 years for the school to give me a laptop to teach from. Oh, I gotta share that. So I'm playing around with some of the new features as now we've gone to digital. Here is the stuff about the sun. So everybody should see that. I'm off in the corner. I think I've got these right. Girl Scouts at home and our flat Juliet. So there she is. And this is me. I was also invited by the Nebraska Space Grant to represent the US at a teaching and mentoring conference back in October. So that's me with the official NASA banners behind. What we're gonna do is we kind of did our welcome. We're gonna talk a little bit about sun safety as we approach into summer. People are outside, and especially with not being in school every day, we might be spending more time outside and less time with groups of individuals. We need to talk a little bit about sun safety and how we can do that. And then the science part, I'm going to talk a little bit about heliophysics, a big scary word for studying the sun. Some of our mission updates as part of my solar system ambassador. I'm going to talk about a couple of my favorite sun missions. They have awesomely cool pictures, like my background picture here today is, I think from either this, yeah, this one's from Solar Parker Probe, I think. And then we'll do some other activities, and I've got some open floor question time. So the first thing is never look directly at the sun. if you're a little bit older, you probably were around and you participated in the solar eclipse. So here's my daughter with her NASA solar glasses, checking it out. This was a couple of months before the eclipse. As a planetarium person, I spent about a year and a half planning for this eclipse that Omaha was not even in totality, but lots of Nebraskans were. The sun is 93 million miles away on average, but it still does a lot of damage. So even wearing your sunglasses, they're very helpful. And yes, use your sunglasses on those sunny days, whether it's in the winter or in the summer. They will help protect your eyes, but you still get eye damage. Think about some of your grandparents and some of your great-grandparents, if they're still alive. How many of them have really good eyesight? They don't need reading glasses, or they can see easily at a really far distance. Not too many. And that's because everybody experiences some eye damage. You can't completely protect your eyes from the sun's rays. So sunglasses help. And then if you still have your solar glasses, if they're not damaged, they are also usable to look at the sun. I should have taken these out earlier. Let me stop sharing. So I have still a great plethora collection of solar glasses. And as long as they're not damaged, kept them in a nice flat spot, you can use them to look at the sun. I've even got some back from the transit of Venus. So if I look up at the lights in my office, you can't see anything. Remember those from solar eclipse days? They're still good, undamaged. You can definitely use them to look at the sun. But that's the only thing. You need a special solar filter. Are you ready to learn more about the sun? Oh, here, before we switch slides, let's look here. This is another way. A lot of people are like, well, I don't know what I do with my solar glasses. I can't use my sunglasses. How can I learn and study about the sun? Well, one way is to make a pinhole camera or a projector. So here's a picture. It's just a sheet of paper, cardstock with a hole popped into it. And it projects onto another sheet of paper. Now this distance between the two sheets of paper may vary, depends on your hole size. But if you have bright sunny day and the sun is very active, and we'll learn about active sun, you should be able to see a sun being projected. And if it's very active and their sunspots are fairly large, you should be able to see sunspots with your little pinhole projector. So very simple, easy way to look at the sun safely, but not directly. So you're looking at the light passing through the hole onto another sheet of paper. Don't stick your eyeball up here to look through this hole. That's doing eye damage. So here's another fun activity. This was me and my daughter yesterday. We made shadow drawings. We went out in the afternoon and she stood here and she made this cool shadow. I traced it out. It was actually about 2:35 p.m., but I put 2:30 p.m. And then we went out again right before dinner, 5:15 p.m. Oh my gosh, my daughter has grown really tall up into the grass. So if I would have shown you the picture over, oh, I'm cheating. Think about it. Where do you think the morning shadow would be? So we've got a little bit afternoon shadow. What shape would it be? Maybe you need to go out and do an experiment and trace your shadow. How does it change throughout the day? Another activity that wasn't in the Girl Scout booklet, but there's lots of ways that you can make a sundial. So this is one way to make a human sundial. I traced out her footprint so he knows we stand in the exact same spot. And every couple of hours, trace out your shape or have a friend trace your shape out. So that's a day. What would a year look like? That's another type of drawing. It's called an alumna. And I say, a what? This is one of those funky, cool words that I still am working on pronouncing. I have to think about it. And I've been doing astronomy for a long time. But it's a figure 8 pattern. So if we were to look at the sun, not directly, but at the shadow, mark off where the end of the shadow is, just like here's this light post. And they went out every day about noon and they marked the end of the shadow, and it did it for a whole year. This is at the University of Oregon. Our pattern would look something similar. But it makes this really neat figure 8 pattern. If you live closer to the equator, it's a little bit more like 2 circles. Their circles are even. And if you live in the southern hemisphere, it's more like this, where the bottom is a little bit bigger. So this was taken with special cameras to put a filter on so that the camera didn't get damaged, and stack the images of where is the sun. The equinox, so where we just had an equinox mid-March, equal day, equal night, that's where it crosses. That was the spring and fall. The sun at its highest point would be summer. The sun at its lowest point would be winter. Kind of cool, huh? And this one is from the University of Oregon. You can look it up. There's actually like a Facebook following of these alumnas. And they've got them over huge, like 7 wonders of the world type thing. Lots of historical places. An astronomer has done a Photoshop like this, photo shooting. So that's what your shadow path would look like if you could do it for the whole year. Just remember, if you're using sidewalk chalk, when it rains, it disappears. So spray paint with mom and dad's permission if you're doing something permanent. Maybe your school could. For our science talk, we're going to talk about heliophysics. And the ambassadors, I think, are the booklet that I've got, the actual Girl Scout NASA heliophysics. So this image. This is one of my favorite images. I love the sun with all the different wavelengths, this cool rainbow effect. And each different wavelength, a scientist is looking at something slightly different, looking at the differences. In one image will look different than another image. This was all captured with the Solar Dynamic Observatory. That's a 3-minute time period. He took all those pictures. Heliophysics. Well, what is heliophysics? It's the study of the sun. So what are they studying? They don't just study the sun, but they also study the weather of the sun. The weather of the sun does affect planet Earth quite a bit. They have explorers that go and study the sun. They're studying the magnetosphere, magnet sphere. Earth is a magnet, it spins. That's why we have a north and south pole. It acts like a magnet. The sun does too. A lot of these, and I'll zoom into some of these other pictures, but these are a lot of generated solar flare, solar energy is because of the magnetosphere. It kind of makes that looping pattern. So that's the sun acting like a magnet. Heliosphere. Helio means sun. Sphere means kind of a surrounding. There's kind of this solar wind that's part of the solar weather, but there's this zone of protectiveness. A lot of Earth's probes, a lot of NASA satellites and stuff are within the Earth's not heliosphere, but within the Earth's magnetic sphere and the Earth's sphere. So the sun has another sphere where it kind of pushes out a lot of the bad stuff and keeps a lot of the good stuff in. And living with a star, so as of course, a lot of people want to know about solar eclipses. You can't have a solar eclipse without a sun, or a lunar eclipse for that matter. So their questions, a heliophysics physicist's main questions: what causes the sun to vary? How do Earth, the planets, and the heliosphere respond? So, what happens when we get hit by a big burst of energy? We're going to be a citizen scientist today and find out about auroras. And then, of course, what is that human impact? When that cosmic microwave background hits us, or we get a large solar flare toward us, how does that affect humanity? What happens to your cable TV or your satellite dish? This is 600, this A with the weird symbol above it, that means angstroms, okay? The unit of measurement. We'll see a couple of pictures with A being measured. Missions. So what's out there for satellites just to study the sun or related to sun study? There are currently 19 missions operating, 26 spacecraft. Some of these are multiple spacecraft. Some of my favorites are SOHO and this Solar Dynamic Observatory. Those are the two that I'm going to show you. They often have a couple of satellites that bounce off signals, so you can get like the sun in 360 degrees. It has one mission in implementation. That means they're working on trying to get it launched and started. And then 4 missions are in formulation. That just means that, they're still working on putting together a package and building the satellite to go out into space to study. The colors over here relate to the titles, and it's where they're operating. So the formulation is the ones that are still kind of on Earth that they're putting together and building. The implementation one that's out here, the solar orbiter. Where's my mousey? Underneath the word solar system. There, I think that registers. Right here, the solar orbiter. That actually was launched recently, and I think I have a little bit of information from that. And then a lot of them are extended. So NASA builds their satellites so well, if they're not broken, they're still using them. Voyager 2, sent out in the 70s. They're still using it and getting information. So why does NASA observe the sun in different wavelengths? I kind of already gave you the answer to that. Look at this picture. All the different ways. Every picture, you'll notice something else kind of stands out. Some of them have swirly patterns. Well, they're probably studying what this swirly stuff is. Some of them you could see has the rays, the energy coming off. Well, what does that mean? Some you can see a little bit more of the whirls and the loops from the solar flares. Some of them have these dark spots on them. Maybe they're studying sunspots, hot spots on the sun. All those different wavelengths, you notice different pictures. I had mentioned the A for angstroms. This is the different energy levels. Each picture, I see something different. It's the same object. This is all within that 3-minute span of the same thing that's happening here. But I notice different things in each image. Scientist wants to know, and comparing different things. It's like going out and comparing your neighborhood to grandma's neighborhood. There are lots of things that are the same, but there are some things different. And why are there differences? Scientists are always asking why. So mission updates, Solar Dynamic Observatory. This is, its main goal is to look at the magnetic changes. Magnets have a lot to do with the shape of these solar flares and solar energy. Also took a picture of the transit of Venus here back in 2012. It was launched. This is just the poster. Let's see what else. Trying to think of what else did I have for it. Yeah, I want to say this is where most of my cool colored pictures come from in this PowerPoint. That's why I included that one. I don't know a ton about the actual present research going on. I just like the pretty pictures. The one that I'm following the mostly for the research on the sun is the Solar Parker probe. It just had its 4th closest encounter. So to set up its orbit to go around the sun, it actually goes around Venus and comes back. And it'll eventually get this nice path that gets closer and closer to the sun. This is the instrument that has broken lots of records. So on this 4th close approach in January, it broke its own record of speed. It's the fastest human-made object as far as going close to the sun and speed. So big, huge numbers there. 244,000 miles per hour. Yeah, cars don't go that fast. But the Solar Parker probe does. And it is only 11.6 million miles away. Remember at the beginning, the sun is about 93 million miles away from Earth to the sun. Well, Solar Parker probe is only 11.6 million. That's a big number, but considered close. Heat shield. So this instrument was designed with a special heat shield. You can kind of see that there's in the picture that there's this big flat plate on it. And then around the edges, there's kind of like these radiator coils. But there's a special fluid in there to keep the instrumentation cold. And it will react to temperature. So as this probe gets close to the sun, it engages its heat shield. And when it was only the 11.6 million miles away, it was the heat shield was experiencing 1,134 degrees Fahrenheit. 32 degrees Fahrenheit is the freezing point of water. I'm more of the scientist. I like to deal with Celsius. So it was 612 degrees Celsius. Water boils at 100 degrees Celsius, 212 Fahrenheit. That's a lot hotter than any other object. Venus, planet Venus, is the hottest planet in our solar system. Its temperature is nearly 900 degrees Fahrenheit. And then the instruments that are hiding behind that heat shield, they were at a nice 85 degrees Fahrenheit. A little bit warmer than the day that we had yesterday in Omaha. So that's a nice spring summer day. So in the next couple of years, in between 2024 and 2025, as the orbits are getting closer and closer to the sun, the heat shield, we're going to test it to see if it can handle 2,500 degrees Fahrenheit, or over 1,000 times, actually over 12 times that of the sun. Or not the sun, but boiling point of water. So 2,500 Fahrenheit, 1,370 degrees Celsius. Pretty hot stuff. SOHO, this is the other one that I used to use a lot. This is the solar and heliospheric, so solar and sun sphere observatory. And I like it because it's got this cool citizen scientist project called the Sun Grazer Project. The website is not the most friendly, but I'm going to take you there and show you. The upper left-hand corner, the green sun's there. That's a different wavelength. That's ultraviolet, so those are UV pictures of the sun, and that was taken with the Solar Dynamic Observatory. So I threw that in, even though this is the Soho page. So let's take a look at the Sun Grazer project. Along with that, I'm going to show you the other one that Girl Scouts has, the Aurorasaurus. Those are two citizen scientist projects. By the way, Citizen Scientist Month is this month. So go out and start being a scientist, helping NASA do real science research. Yeah. So real science research. Let me pull up another screen here. Onto my web page. Come on. I'm trying to show you my screen. There we go. There. See how that looks. So this was from the Solar Dynamic Observatory. And I just went to the I can show you how I got there. So I went to the Heliophysics. There's NASA Heliophysics Division. I gave you that link in the PowerPoint. There's the Science Mission Directive. And you can just go into the missions, and they'll have all these different missions. I went to the Solar Dynamic Observatory, and I like this one because you can actually see where it is. So real time, where is the Solar Dynamic Observatory? And they've got this simulation of it. So White Sands is the one who's operating it. But here's the simulation. And you can see how it's mapping the Earth and then looking back at the sun. So it's getting its GPS fixes. And there's the sun's North Pole and taking a picture. I just thought that was a neat part. This is its path. That's where I also got a lot of the pictures. Solar Parker probe, which I gave you a lot of information on. Where is it? You can see here's the orbital paths. It's got the first three darkened in. 1, 2, 3. We just finished 4. Now coming back away from 1, 2, 3, 4. So that's the 4th one. Close to the sun. This is distance from the sun. It's going to head back toward the sun now. And you can see animations. NASA has animations for lots of different things. But this is the launch information. And it'll give you live updates. So this is its distance, its speed. So you can always track new kilometers, which is SI units, or miles, which is your standard units. This is just a simulation showing you how the heat shield is facing. Latest news, February 5th. Oop, that was the one. Yeah, that was the one I wanted. So the sun grazer project is a little bit older. It's a citizen scientist project, but it is, you're discovering comets. So you're using the sun to help identify comets as they go flying by around the sun. So how does it work? So you download these images from either Soho or Stereo, and there's lots and lots and lots of images. And then what you're gonna do is, usually they ask for a registration, so make sure you check with your family and see that it's okay that you can register and look at these pictures. And then basically how you participate is you contribute. So well over half of the known comets have been discovered via the Sun Grazer project. They have as young as 13. So they really need to update their website. But they've discovered 3,729 comets by having people like you and I just look at these pictures and help the scientists determine, is that a comet or is that just a flash in the image? So kind of cool. The other one that I like, and this was on the Girl Scout book, not Aurora. Let's see here. Aurorasaurus. Now, I like auroras. However, it's not too often. I change the time here. Go to midnight. See where the shadow is on Earth. It's not too often that we have the chance of seeing auroras way down here in Nebraska. However, it looked like somebody tweeted about auroras. Let's click in there. Oh, Sean Harris, there's a race. Supercomputers, breakout. I'm gonna say that his info is not about, did he just see an aurora? No. So some people have tweeted. And so I've had fun, even though I don't get to see auroras, sometimes I go in and look at the tweets and help the Aurorasaurus. Right here, breaking news, pedestrians killed, hit and run collision on Aurora Avenue. Do you think they actually saw an astronomy aurora? No. Well, sad news, that is not an aurora. Even though I can't say, yes, I've seen an aurora and I verify it, and I just help them verify with their tweets. How does this work? Again, you can look at the chances. So there's the day-night line. There's your legends of what things mean. We're gonna make it nice and big. So you could go in and what you do is you enter where you live. And if you're actually observing an aurora, here's the probability. We turn it to, how about April Fools? What was happening yesterday? Way up here. These guys have a bet. They only still have a 10, 20, maybe these little itty bitty circles, they might have a 50% chance at seeing aurora. I go to solar weather, and that helps me too. with determining, is there a chance for me to see an aurora? It's run by NASA and NOAA. So there's your space weather. Here's our picture of the day. This is what the sun looks like, right? Oh, there's a sunspot. It's sunspot 2759. We have been at a solar minimum for a long time. There's an 11-year cycle. And so seeing a sunspot is kind of cool. It's also tracking comets here. Oh, here's your aurora circle, the circle of auroras. Corona holes. Hey, that was the probe that we were looking at. Solar Dynamic Observatory. Solar winds flowing from minor corona holes could reach Earth on April 4th or 5th. If that energy reaches us, that might be a better chance for some of those ham radios. If you like CB radios, their energy gets boosted, their signal gets boosted when they have solar energy, solar winds. Real-time aurora photo gallery. Space weather is a great place to go to learn a little bit about what's happening with the weather. They also include some near-Earth asteroids, comet rays. That's the current conditions. You look at Earth's weather conditions. Why not go check out the sun's weather conditions? Got a couple more activities for us. I think that's it for my slides. Let me double check here. Oh yeah, next is up for our activities. So we're talking about lots of cool colored pictures. So we are going to, or you can make one of these disappearing color wheels. It's about a 2-minute video. Walk you through it. Things you need. This is coming straight from the Girl Scout book. This is actually, this color spinner is, I think from the junior badge book. Scissors. And the Girl Scouts have you cut out a piece of white paper and a piece of cardboard. Then you're going to make a disc. And you're going to color the 4 zones. Girl Scouts suggested colorful pencils. He's using markers there. Rulers to help draw a straight line, scissors, glue. So you glue on your color disc. The cardboard helps because you need a little bit of weight. This is kind of off of an old-fashioned button game that they used to do. If you think of, go to any of the reenactment places, they'll put a button on a string. So you wind it up. That's it. So you can look at how color is done. So I did one, my daughter did one. Just a color wheel and string. The video does it a lot better as far as whether you can see the colors are white. So that's one of the cool activities from the Girl Scout book. Another one to go with our sun safety. I'm gonna take off the background. I tried doing this earlier, and my cool video virtual background does not work. So there's my lovely office in the background. And what you need to do is take a dark sheet of paper and some kind of plastic sheet, clear plastic sheet. And what you do is you put sunscreen on your hands or put sunscreen on your drawing here on your sheet, and you can draw out a picture, set it out in the sun, let the sun bleach the paper, and you'll have this cool sun print. So I tried doing it yesterday, and of course the wind took my paper and blew my sunscreen into a dirty mess. And just remember to weigh it down with a brick or a rock or something, because it will blow away, especially in Nebraska. Let me think. I think that's all that's all I've got. Is there anybody with questions or has a shout out about anything? I can open up, unmute anybody who wants to ask away. So you're free to unmute and ask, or type in the chat too. You can answer chat questions for us today. And I will send Renee the PowerPoint with the slides. So I can share out. The last couple of slides in my PowerPoint are actually where I took this information. So from your resource guide, if you're a daisy, a shadow poster, that's kind of what we did with sidewalk chalk. Your pinhole projector. I don't know if today's sunspot is big enough to actually show up on the pinhole projector or not. Your day sky book that they have is similar to our sidewalk chalk thing, observing where you think that the sun will set or rise or how it moves across the sky. Brownies didn't really have anything specifically sun in my mind. There's this really cool, if it was warm, I was going to do this circle the sun dance. So Dance the Earth Year, that's a junior badge project. So we constructed a spinner, part of the cadets program. If you have a piece of glass, a lot of girls like to play with prisms. So there's actually some prism pictures that you can draw or make a rainbow. The sun print, I forgot to talk about that in our safety, but that's that sheet of paper with sunscreen. And exploring more than your eye can see, a lot of our science talk came from looking at that. Our seniors, see how your eye reacts to light. So shining your eye and measuring how your pupils change. You have a light source, not the sun, but another light source in your eye, unless you're going from a dark inside building to outside in your backyard or front yard. Heliophysics. That's where we got a lot of our, actually all of our science educational information. Our citizen scientist project, Aurorasaurus is the one that they showed off, but I also showed you another one on finding comets, so not specifically sun related. That's our sources. Get any text messages? I don't see any from Renee.
No, I
Got
think.
any questions or anything else we want to share out? Covered a lot of stuff in a very, very short amount of time.
Yeah, I don't, if there's any other questions, you can post them in here. Otherwise, we've got programs coming up tomorrow. Anyone can tune in for, let's see, I'm going to check the calendar.
Okay.
Tomorrow's Friday. We'll have in the morning a virtual tour of Lakeview Cabin, Lakeview in North Platte. And then in the afternoon, we have budgeting for your camp out. So some like entrepreneurship, financial skills, specifically around Girl Scouting. And then don't forget to use your flat Juliet and use the tags hashtag Girl Scouts at home and hashtag GSSN for
Okay.
share that if you are interested and see to show what your flat Juliet and your Girl Scout are doing when you're at home, staying safe. Yep,
We're just
there's
hanging
flat
out with
Juliet.
the sun today.
You should take a picture of that, post it
Okay. There
with
you
the
go.
hashtag.
Okay. I'm
Right.
working on my social media skills. I'm going to stop recording in case anyone wants to ask questions outside of the recording time. So I've stopped your recording.